All right, for those of you who made it here to the homework, good job. I'd like you to copy all of the work I'm going to do onto these 4 problems right into your packet. So you're going to do all this work right on the packet page. So for these, we want you to graph ordered pairs and then see how they relate to these equations we've been talking about. So again, x-axis is the horizontal axis. The y-axis is the up and down, way up high axis, way up high, x-axis, y-axis. These x-axis numbers will be written down here on the x-axis, y-axis numbers written up here on the y-axis. Looking at this scale, I'm going to go up by ones. So starting here at the origin, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going on the y-axis, 0 here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So number my x and y axis just like this. Label them x and y. We want to realize this is a coordinate. This is the coordinate 0, 3. And again, always x for the first coordinate, y for the second, which means over 0, up 3. The next point, 2, 7. 2 comma 7, 2 is x, 7 is y, over 2, up 7 for that one, over 2, up 7. Next point is 3, 9, so over 3, up 9. And then the last one is 5, 13, over 5, up 13. Draw your line best you can through that. And then I want you to see this, what I'm seeing. On this line, there are points that are not in this table, but still on this line. I want you to see that. This point right here looks the point 1, 5. That is on this line. If there was a number right here between them, that would be 1, 5. This point up here is 4, 11 would fit in there, 4, 11. So even though those numbers are missing, they are really there on the table, on the graph. And then once you get all those x numbers going up by ones, then you're golden, because then you could look at the rate of change for your y numbers if your x numbers are only going up by ones. If these are going up by 2, that is your rate of change. That is your slope. Your 0, 3, that is your y-intercept. Look how they match. The y-intercept 0, 3 on the graph, the y-intercept on the table. The slope over 1 for x, up 2 for y, put together as rise and run, 2 over 1. That's the slope of this line, or how much it's increasing by the rate of change. That matches this. And again, if you were to write that equation, it would be y equals 2x plus 3. Any of these coordinates will plot into x and y and give you true statements. Any of these points on the line, 1, 5, plug in 5 for y, plug in 1 for x, ends up giving you 5 equals 5. All these points are a solution to this equation. All right, next one. We want you to label the x and the y axis. Want you to put those numbers down. Label the y axis. Plot those points. So 0, 14, that is the y-intercept. 0 for x, up 14 for y. The point 4, 10. The point 7, 7. The point 9, 5. Draw your line best you can from this y-intercept point all the way through. And then again, you'll be able to see these missing points on the line. This is the point 113 is in there, 212, 311. They are all sandwiched in here. They are not missing. They are part of that data, but just not written. The graph kind of shows them where they start to show up. But all of those numbers are fit in between there. And then you can see now you're going up. Oh, not going up, going down by 1. Y-intercept's 14. This would be y equals negative 1x plus 14. All right, let's keep going. This one going left to right uphill, positive slope, positive rate of change. This one going left to right downhill, negative slope, negative rate of change. All right, last two. Label the x and y axis. So 0, 1, 2, 3, 4, 5. Label the y axis. All right, this is the point 211 over 2 up 11. This is the point 410. This is the point over 6 up 9. And then over 8 up 8. Draw your line through those best you can. And again, this one's a little bit more tricky, but you can see the y numbers are going down by 1. But this is a little trickier because the x numbers are going up by 2. So if you had to write the slope of this line, which is rise over run, or the change from one y to the number over the change from one x to the other, the change from one y to the other, and I'm going to fix this. It goes rise over run, so the change in y on top over the change in x on the bottom. So my change in y is going down by 1 from one term to the next. My change in x is going up by 2. So the slope from this data is negative 1/2. Look how it matches the graph. Over 2 for my run, down 1 for my rise. This line shows the same slope as this, negative 1/2 slope. I want you to see that with a y-intercept of 0, 12, y equals negative 1/2 x plus 12. All right, last problem. This is x, this is y. Label the x-axis. Label the y-axis. The point 1, 4, the point over 2 up 7, the point over 3 up 10, the point over 4 up 13. Draw your line best you can through it. I can see that this has everything we've been talking about. The x numbers are only going up by 1, so I don't really need to worry too much about dividing. 3 over 1 is still 3. So only when your x numbers are changing do you really need to worry about this. If the x numbers are going up by 1, not a worry. It's just 3 over, which is just 3. And then again, that slope matches the slope of my line, over 1 up 3, over 1 up 3. That is my slope of that line. That matches this data. Every time x goes up by 1, y goes up by 3. That's what this is showing. X goes up by 1, y goes up by 3. My y-intercept I could see is 0, 1. And I could again get that from the graph by doing the opposite. If this is going up by 3s, subtracting by 3 going the opposite way. So if I backtrack from here, 4 minus 3 gives me positive 1. If I backtrack 1 here, 1 minus 1 of course gives me 0. So the 0 term would be 4 minus 3 would be 1. There it is, matches the y-intercept. My slope matches my slope of my line. And if I was to write this equation, that would be y equals 3x plus 1. If I put that slope in the right place and I put that y-intercept in the right place. So 1 goes right here, or 1 from the table. Same thing, 1 from the graph, 0, 1, 0, 1 from the table, right there in the y-intercept. 3 is your slope, your rate of change. So this one is y equals 3x plus 1. And again, any point on this line will plug in and be a solution to this equation. If I plugged in 1, 4, 4 for y, 1 for x will give me 4 equals 4. If I did 2, 7, 7 for y, 2 for x, you'd end up with 7 equals 7. Alright, the last part of your homework. After you've copied all of this into your packet, I would like you to go to the class document and find this slide here where I made up one. I would like you to right click right on here and copy it right onto your own slide. Easy to do. And then I want you to try to do this work on your own Google slide as much as you can. Show me as much as you can about this after watching what I just did. So this problem, copied and pasted onto your own Google slide, the one with your pictures that you have shared by last name, first name, period. Copy this onto there and try to use the tools with Google to show as much work as you can. Good luck.